Please everyone give a very warm ShmooCon welcome to Falcon, Darkstar, Momot for SQLi's So Last ShmooCon.
Well, thanks. And yeah, this is it's so unfortunate that this is the last time that I'll be doing this to the sound of the braying Alaskan moose. Thanks for coming here to talk about why it is that we keep having SQL injection and how not necessarily every API needs to be a REST API. Just like 3 seconds about me. Product security manager, this little managed database company called Ivan. Check us out, we're cool. But just finished an MBA and a master's and bachelor's in accounting this year. Random stuff, and I've just been exploring kind of what a data platform looks like a lot more over the past little while. So, SQL injection, as a LangSec person, I just can't abide this business of sending our whole data interchange that we do for basically every application on every database-oriented stack out there, which is basically all of them, being a data interchange format. Just kind of sucks. You don't really think of it that way. Like the SQL statement is code. Why do we have to have every interchange language that we use for all the most sensitive data that we have be completely programmable? I know that SQL is maybe kind of old, and that's part of the point of this talk, really. But please stop exposing all powerful interfaces for these things. So yeah, you can see the statement. It includes all the data in red. It includes some parameters that are often user configurable but are really code, which I talked about 2 years ago on this very stage, describing how it's necessary to sometimes make a compiler to output these things. In this case, I'll be concentrating a little bit more on the data side of it. So a couple of quick things to get out of the way with respect to SQL. Aren't prepared statements enough? We know how to do this, right? Well, prepared statements aren't quite enough. Kind of as I was talking about before, at minimum, you sometimes have this problem of like, which relation are we going to insert these things into, or which relation are we going to be querying these things out of? Sometimes it's a little bit dynamic. The big culprit here is things like search filters and stuff. But either way, you need more than just prepared statements for this. The other thing with prepared statements is, occasionally you'll crop into some kind of bug where it's possible for you to escape the channel anyway. For example, consider not only a bug in the SQL library, but also something like code execution, SSRF, debug code that's been left hanging out in prod. The presence of prepared statements in your application does not provide an absolute guarantee that somebody can't just, for example, steal the database credentials from your application server and begin using them anyway. So neither this nor writing compilers is enough, really, to offer us a full degree of protection against this. I also have to make the obligatory mention of ORMs, because somebody is always telling me, well, if you hate SQL injection so much, maybe you should just use an ORM. Well, a short list of things that an ORM can't do is on the slide, but I also want to point out that several ORMs have actually ended up having SQL injection bugs in them. For whatever way they were constructed, it turned out to be possible to exploit some of the ORM calls to execute arbitrary SQL anyway. So that didn't really help us. Now, the question that we really should be asking ourselves is, why is it necessary to create all of these root users and have them used constantly? In what other environment do we just run all of our code as root? Well, it's kind of the default way to do it in Postgres ever since WordPress decided that it wanted a root role in MySQL to do self-updating on its schema from the web interface. Great anti-pattern, don't do that. So Postgres too has users other than root in databases. Just talking about the ancient arts here, this is very common in data warehouse and analytics applications, but like normal B2C user applications do this kind of thing pretty much never. But there are these roles. They're basically users. You can assign permissions to them. The permissions can be a lot of things. The permissions can be, for example, not only which family of SQL do you want to execute from, so data definition language, modification language, query language being the 3 major tiers of that. You want generally to avoid your application doing data definition language, which is defining what the schema for the data is, setting the types for everything, describing how you can interact with the data. But you usually need it to do some subset of DML and DQL. So in any good database management system, such as Postgres or any of its alternatives, you can generally give permission kind of on different levels than just this. You can say, okay, these are the relations or tables that you can manipulate, and these are the kinds of things that you can do to them. And you can occasionally even use this thing called row-based access control, which is these are the rows that you can access based on this other. It has a whole conditional access control system built directly into it, and nobody uses it. So the point here is you can grant a user permissions on each relation, specific permissions, and you can grant access to other things that are not the relations directly. You can kind of force your user to go through an abstraction layer. You can grant them permissions to have a view of the data, maybe with one or another column redacted, or let them use a function that allows them to interact with the data in a specified way without necessarily giving them full read-write access to the data itself, as long as you define it as such. So a brief detour into exploitation models of Postgres, which is both necessary to understand this and really as a pen tester, very enlightening if you happen to encounter one of those applications that is in the data warehousing space or something where you don't necessarily have superuser. Or even if you're a pen tester and you want to figure out what you can do with superuser to escalate or pivot. Of course, there's execute, which is what it sounds like. Compile this string into SQL and run it. There's a little thing called security definer, which I will talk a lot more about on the next few slides, but it's basically the equivalent of a SUID bit for SQL things. Run this function or procedure or other code as the person who wrote it rather than as the person who is running it. Create extension, literally pull this .so file off disk, install it into the DBMS. When you call a function with a particular name, it executes code from the .so. This is something that exists in Postgres and some other DBMSs. Kind of very interesting if your goal is RCE. Anytime that you have the database root user, you can use this. As long as that .so is on disk, which is where we get to the rest of these calls. Copy to program is literally just system. Execute this program and pipe the data from the query into it. Create server for and data wrapper. You can connect out to another server, maybe even another database on the same host or something that you might have a TLS certificate for. Won't be using that in this talk, but it's kind of another cool way to escalate from superuser. And then if you want that file read-write primitive to be able to upload the .so so that you can install it with create extension, PG large objects, import and export extensions are your friends. We've seen this used a fair bit. So moving right along from there, how about instead of having the default user that our application runs at be able to do all of that and you get SQL injection and you can just pivot directly to the database user on the system and start reading and writing arbitrary files? What if we made a role and we granted them access to only a few things, such as this thing? This is an example of a stored procedure. It allows you to do a particular defined operation against the data. And that's kind of where I'm going with this, is how about instead of using the database as a disk that people can just read and write, what if instead we defined, in addition to our schema, which is the structure and relational structure of our data, the ways that you're allowed to interact with that data, and then restrain your application to just those little things. So that looks a lot to me like an API. APIs don't have to be REST. If I define all of these functions, well, there's GET requests and PUT requests, and I can map them kind of one-to-one to SQL operations. There's queries that return data that you make in a specified way, and that's an API call, and there's queries that update something in a structured way, and that's an API call. So as to permissions, remember how it used to be with Unix, you would write applications while we're using all of these old tools. You would write some Perl scripts or something, and you would give a lot of them the SUID bit, and then users could interact with the thing that was maybe a file somewhere else and make structured updates to it according to what your Perl script would let them do, without necessarily being able to read-write that whole thing themselves. Turned out to be very helpful, and that's also helpful for us too. If we change this procedure and say create or replace function, but we include this text in green here, security definer. Well, that's our SUID, and now I don't have to give you access to that underlying content or that underlying post table at all. You can just run this procedure and it uses its access to allow you to do just this one operation. And that's a little bit better. I can put other semantics in here than just you can only access these rows and do those operations to them. I can make it conditional on parts of the request. It's the next thing that we'll get into. So, and if we don't make a delete procedure at all, they can't delete things because they don't have read-write access to the table. So now users can't redefine the data access API. That's our whole purpose in this, right? We don't want SQL injection to lead to, oops, I've just dumped all of your data that you have ever had and I'm going to run off with it now. They can still exceed their application level authorization with SQL injection, though, for example, by passing arbitrary parameters. So we have one more problem left to solve with this architecture. And what that is we need to bind the database request to the application user. So we've got basically two options for that, a stateful option, which really sucks, and a stateless option, which is kind of cool. And what this is going to let us do is kind of my favorite pattern of all time. Somehow or another, the user which is making the request is made intrinsically part of the request, and you can do conditional access control based on who is authenticated. So here's a stateful connection binding. You have to have the client connect. You have to assign a sticky worker to the client. You've got to open a connection for the client. I'm so sorry for the eye chart. Request the connection ID, get the connection ID. It turns out Postgres gives you a connection ID that is like static, and you can hash it and stuff and bind it to a particular connection and figure out which one it is later. And where that comes in handy is you ask for that, you tell another auth server that is allowed to do write to the permissions and does actually have root on the database, or maybe just the option to bind users, I don't know. You tell it, hey, this connection is associated with this user, and then every subsequent query that you make, you can join that table in and say, okay, based on this connection ID that I know ambiently, this is the user that is, and they should only be allowed, for example, to query and edit records associated with that user. This kind of sucks because you then have to have one database connection per user of your application, which does not scale very well. A lot of applications were written using this kind of thing, so if this is native for your application, for example, remember ASP.NET View State, maybe you can use this. But what if it was stateless? Some nice person wrote a little library for Postgres called PGJWT, which does what it says. You can just validate JSON Web Tokens inside of the database. So I authenticate with my IDP, I get my JOT back, I send my JOT along with my request to the server. The server sends my JOT directly along to the database. It authenticates it first, of course, but the database isn't trusting the application server anymore, it trusts the JOT. The JOT goes, you check it, you check whether it was revoked, and you get the response back. Now the only thing that you're trusting the server to do is not tamper with or harvest that JOT, which is a whole other problem, much harder to solve. But in this case, the database can make its own decisions. It doesn't have to trust that the application is running. And if the user that is under attack now just isn't there and isn't authenticating, well then you just can't get in until they do. So we've tightened it a little bit. We haven't tightened it fully. I just want to point that in there. This is not a silver bullet. It protects against very specific threats. So this is basically how you would use pgjot. Let's create a function check user. It takes on that jot, returns a NUID, and all that it does is it invokes the verify function. Remember before how I said you can put a .so? That's what this is doing. That verify function isn't natively in pgsql, but you can add it by installing the plugin. If not, the authentication check passed, then raise an exception auth failed. You can just do that. You can break out of these stored procedures anytime you want. So you can create application logic that says, this operation not allowed, kick you out, and just raise an exception before it goes, and the exceptions go back recursively up the stack. The other thing that's kind of cool here is that most modern database engines now just kind of natively support JSON, so you can just query things like the UID right out of the jot. And so lastly, here's an example of us putting this all together and using the API. Create a procedure to update my profile. It's security definers, so you have to be, you can call it, and you don't have to have permission on the underlying table to use it. We just very easily declare one variable, check the user with the jot to get their UID out. Now that's trusted because we pull it out of the trusted jot. And then we say, populate the record from the JSON that the user sent to the web server, just pass it right into the database. The database can parse it out using the types from the table that is underlying. That's what that null : profile is doing. Transforms it from JSON into a kind of temporary table. And then you can just set the variables in your update, and the query is predicated on that where ID is the UID that I got in from the beginning. So yeah, I'll just talk about this for a little bit, and then I'm pretty much done. I'll open it up for questions. So the interesting thing about this is kind of an open problem. This is an unfamiliar pattern. There's a library that you can use, for example, called PostGREST, P-O-S-T-G-R-E-S-T. And what this does is it's a web server. It's a very thin web server, and it allows you to just expose your database and it passes queries through. This is kind of intended for a more internal microservice type application where the only requesters are all trusted. But in this case, if you defined your APIs in this way, there's very little that stops you from simply opening the database connection to the internet and using it. I mean, check that first. It wasn't really designed to be used that way of late, but you could in principle, because remember, you're authenticating as this public user, and the only thing that you can do is you can call things that are part of this defined API. So now you've just kind of chopped a whole layer out of your web application, and all of those vulnerabilities that might have existed as you tried to enforce these rules, they either don't exist or they're things that you can analyze solely on the SQL layer. A lot of the time with this, applications that have this kind of logic and also use execute will sometimes give rise to what would be called an injectable stored procedure. And you can see from the complexity of this code that it would be fairly easy to write one and difficult to find one unless you're using a static analyzer on the code. So do watch out for that pattern. This pattern isn't immune to that whatsoever. And in fact, this type of stored procedure can be quite dangerous. Create procedure update profile types security definer, and an execute call in there can mean that that person can then privesc to the super user that defined this process. You can also add another layer to this, whereby you define a more limited user that can, for example, not execute any DML, so defining stored procedures, adding extensions that are .so files. Maybe it can't interact with the PG large objects at all, and we ban that whole file read-write primitive. But it can do all of the things that the stored procedures allow it to do. So you can go very deep with this defense in depth model if you're familiar with the tools that it gives you. So yeah, that's pretty much the whole thing, but I wanted for this one to just leave a little bit of extra time for questions. So I think we've got about 3 minutes for that if anyone does. Yeah, go on right ahead. GraphQL, yep.
Do you think using like GraphQL and Apollo would be a good way to defend against SQL injection?
Well, that's an interesting one. This pattern does not strictly apply, for example, to all of the various NoSQL query languages. Yeah, I'm not sure. If the underlying implementation of the GraphQL somehow does map out to SQL, I think that you could actually use this pattern. And I would love to see other, perhaps newer database management system types, like your Mongos and other things that do sort of a completely different query language with more tightly defined operators, still support things like row-based access control, because it would allow us to have this kind of defense in depth model. I think if I understand the question correctly, how often do I set off alarms as a red teamer when I am making weird queries in the database? That really depends on whether or not your defender has bothered to get query logs into their seam, and getting query logs into the seam can be very fraught because they have a proclivity to be filled with very sensitive data. So it depends. In my experience, typically you will be caught if your query ends up being long running, and otherwise it may take quite some time to catch you, depending. If your defenders are very competent and they're able to get the definition for what you're transacting with your database and filter out all of that sensitive data, that's another thing entirely, and you could be caught straight away. With this, you can catch them almost instantly. All right, there was one more in the back, and then Dade.
Just out of curiosity,
Go ahead.
out of curiosity, what started this research? Like, was SQL
The question being, what spurred this research? Is SQL injection still relevant? Yes, it's still in the OWASP top 10. It's very frustrating. Why specifically SQL? It remains the most widely used. I mean, LAMP or whatever stacks remain so common that it seems to be still relevant and worthwhile. Go ahead.
Yeah, so I'm actually deep in like figuring out how to do database security right now, and this is very helpful for that. One thing that I've been looking at with Postgres is their concept of, I want to say they're called like security labels. Is that something that you've looked at? Is that like a useful construct in Postgres security, or is that kind of like a don't go there, there be driving situation?
Oh, it has so many features, and to be familiar with all of them is like knowing everything that's in x86. All right, am I being told to go away and shush?
I was just asking to repeat the question.
Oh, repeat the question, yes. The question being, can you use security labels in Postgres? And I think the answer... Are they useful? I think the answer is the more of these kinds of things that you can combine, the better. Okay, anyone else? Tara?
How much can you prioritize this for those of us that are using this, that are using RDS in terms of application security
This would be very easy to do if you're greenfielding your application. To rewrite in this might be challenging, but you don't necessarily have to boil the ocean and do it all at once. The question being, for an application, how high would you prioritize making these controls? All right. Thanks again. I haven't missed this.